Francis Zwiers. The future of planet Earth, the health of its ecosystems, and the quality of life of all living things is strongly influenced by climate. Water availability for hydroelectric generation, industrial development, agricultural production, and domestic use underpins human existence and is tied inexorably to climate. As such, our ability to continue to thrive on the great blue marble of our solar system is critically dependent on establishing depth of understanding of how, why, and at what pace our climate is changing, so that policies with long-term vision can be implemented, humanity can be educated, and effective action taken to secure life and ensure that it prospers on the only body currently equipped to support our existence. This is the life's work and calling of Dr. Francis Zwiers, who was inspired to tackle one of the great questions of our time in the second year of his undergraduate degree when he was first introduced to statistics. Motivated by the notion that figures could be used to design experiments and carefully tease information out of data on real-world problems, he began what would be a lifelong quest to constructively develop and use approaches to translate information with its accompanying uncertainty into knowledge for effective decision-making. Earning his undergraduate degree at the University of Waterloo in 1974, Francis Zwiers pursued graduate studies in statistics at Acadia and Dalhousie, obtaining his PhD in 1980. He engaged in public service for 26 years, serving initially as research scientist, then chief of the Canadian Centre for Climate Modelling and Analysis, and more recently, director of the Climate Research Division of Environment Canada. Dr. Zwiers is currently the Director, President, and CEO of the Pacific Climate Impacts Consortium in British Columbia. An internationally recognized expert on climate variability and change, Francis Zwiers is counted among those whose contributions to the work of the UN Intergovernmental Panel on Climate Change led to it being awarded the Nobel Peace Prize jointly with Al Gore in December of 2007. Amongst other contributions, Dr. Zwiers' recent work has helped to demonstrate that observed increases in the intensity of precipitation extremes are likely linked to human-induced increases in greenhouse gases. His legacy is filled with stellar research achievements and sustained contributions to post-secondary training. A Fellow of the Royal Society of Canada, Dr. Zwiers is also the recipient of the Queen Elizabeth II Diamond Jubilee Medal. Francis Zwiers is a humble scientific contributor, a passionate educator, a skilled communicator, influencing and leading the effective translation of science findings into policy and action, a mentor to scientists within our borders and abroad, and a trailblazer who has, with skill and generosity, guided innumerable young investigators to help them make their marks on science and the world. Mr. Chancellor, on behalf of the Vice-Chancellor and in the name of Senate, I ask you to confer the degree of Doctor of Science honoris causa upon Francis Zwiers.
By virtue of the authority vested in me as Chancellor, I admit you to the degree of Doctor of Science honoris causa. Congratulations, Dr. Zwiers. On behalf of all assembled here today, I should now like to invite our newest alumnus, Dr. Zwiers, to address Convocation. Dr. Zwiers.
Chancellor Joe Rockman, Vice Chancellor and President Dr. Amit Chakma, Dean of Science Dr. Charmaine Dean, faculty and colleagues, ladies and gentlemen, and above all, graduates, please accept my very profound thanks for the honor that you've just bestowed upon me. As you've heard, I was trained as a statistician, but I've been immersed in climate science for most of my career. It's been stated that climate change is the defining issue of the 21st century. It is an issue that touches all aspects of human society and the Earth system that supports us. There's no doubt that the climate has changed over the past century, and there is very little doubt about the cause of that change, which is our use of fossil fuels and the use of the land surface. And also very little doubt that climate will continue to change as greenhouse gas concentrations continue to rise. There's also little doubt that humans, through their emissions of greenhouse gases, are responsible for a large part of the observed change. That evidence that we are responsible for a substantial part of the change in climate has occurred over the past century can be seen in many different aspects of the climate system, including surface air temperature, the temperature of the free atmosphere, that is the part of the atmosphere above the surface through which we fly our aircraft, the amount of water vapor in the atmosphere, which has increased along with the temperature of the atmosphere, the distribution of rainfall on the surface of the planet, which has changed in a way that is consistent with our understanding of what the effects of increasing greenhouse gases would be, the salinity of the ocean surface, which has been changing also in accordance with expectations that have to do with changing temperatures and changing distributions of precipitation. The temperature of the interior of the ocean, rising sea levels, and diminishing sea ice cover, Arctic sea ice cover. All of these elements of our climate system have changed in a way that is consistent with the expected effect from the addition of greenhouse gases to the atmosphere. And all of these changes taken together are very difficult to explain in the absence of those additions. It is us that has caused a substantial part of the change that we have observed at a global scale. As Dr. Dean explained, evidence is also mounting that the accumulating greenhouse gases in the atmosphere are increasing the intensity and frequency of heat waves, reducing the frequency of cold extremes, despite your experience this past winter, which is not the uniform experience across the face of the globe, increasing the intensity of extreme precipitation events, and very recently, we've come to understand that there is a human effect that is affecting where hurricanes and typhoons occur, these very large damaging storms that cause tens of billions of dollars of damage. The climate will continue to change in the future due to natural causes as in the past, but dominantly as a result of our continuing emissions of greenhouse gases into the atmosphere. The fundamental physics and chemistry of the Earth system dictate that there will be additional warming, with the amount of warming dependent upon how much we emit. We have a choice as to whether warming in year 2100 will be less than 2 degrees centigrade above pre-industrial temperature levels or more than 4 degrees centigrade. And that choice depends upon the choices that we make concerning how much greenhouse gas collectively we emit into the atmosphere. That change, the warming that we cause, will be essentially permanent on human multi-generational timescales. We stop emitting greenhouse gas into the atmosphere today. We do not expect that global mean temperature will immediately revert to pre-industrial levels. That will take a millennium or two to happen. And so the changes we have caused are changes that are in essence, permanent. There will be further changes in the distribution of precipitation on the planet and in the intensity of extremes, and sea level will continue to rise as time goes along, with sea level rise continuing long after we stabilize the temperature of the atmosphere. And that means populations will continue to be displaced, will continue to have to invest in infrastructure to defend places where we live from rising sea level as a consequence of emissions that are made today and have been made in the past. Moreover, the ocean will continue to acidify, increasing further the threat to ocean ecosystems that is already present as a consequence of the acidification that has already occurred. The carbon dioxide that dissolves into seawater forms carbonic acid, an acid that you're very familiar with because it's part of the taste of Coca-Cola. And that acid raises the pH of seawater, threatening the ecosystems that live in that seawater. A key question is whether a warming of 2 degrees C, for example, matters. After all, this might seem to be a small amount of warming when considered in the context of the rigorous Canadian climate. You surely all would have been very happy if it had been 2 degrees C warmer last winter in this part of the world. The clear answer to that question is that yes, it does matter. Such a warming does matter, particularly when you consider the effect that such a change in temperature has on extremes. For example, the frequency of summer heat waves has increased globally, and evidence is emerging that summer heat is beginning to have adverse effects upon some of the crops, such as corn, upon which we rely, that feed us. Internationally, there's a broad consensus that a warming above 2 degrees C, above pre-industrial, is a threshold that we should avoid because impacts of climate change rapidly increase beyond that point. So there is, in essence, a global emissions budget that needs to be respected if we want to stay below a given threshold, such as 2 degrees C warming. We know now that the amount of warming that we will experience depends directly upon the cumulative amount of CO2 that is emitted since pre-industrial times. And to have decent odds of staying below 2 degrees C, and by decent odds we mean 2 chances out of 3 or better, we will need to keep cumulative emissions of CO2 since pre-industrial times to below 1,000 gigatons of carbon. Now that's a very large abstract number. To place that number slightly within a context we might understand, 1,000 gigatons of carbon is the equivalent emissions to the emissions that would be produced by 1.5 billion liters of gasoline, an incomprehensible amount of gasoline. Like any budget, if we spend now, we'll have less to spend in the future. If we emit more now, we will have to curtail our emissions more rigorously in the future if we are to keep within the 1,000 gigaton carbon budget and therefore have a fighting chance of keeping warming to below 2 degrees C. So globally, we've emitted a little more than half of the 1,000 gigatons already since the beginning of the Industrial Revolution, and that's resulted in 0.8 of a degree of warming. The climate system is still changing, so if we stopped emitting today, it would actually continue warming for a while, and the full warming that would be realized would be a few tenths of a degree greater than that 0.8 of a degree C. So we've already come a fair ways towards that 2 degree C threshold as well. Emissions from fossil fuels and cement production are estimated to have been about 9.5 gigatons carbon equivalent in 2011. And so when other sources of emissions are taken into account, that means at current rates, we have something like 40 years left before we exceed that 1,000 gigaton budget. That would keep us in a relatively comfortable state and avoid the most severe risks to our ecosystems. The implication is that emissions will have to decline soon, and indeed, some climate models suggest that emissions may have to become negative at some point in the second half of the 21st century in order to stay within this 1,000 gigaton budget. That means removing CO2 from the atmosphere rather than adding CO2 to the atmosphere. There are many technological possibilities for doing that, and one where the various components of the technology are actually relatively mature, but none of the components has been combined together to produce a full system, is what's called bioenergy together with carbon capture and storage. We burn biomass, we capture the carbon that is produced and bury it, and in that way remove carbon from the climate system. So unfortunately, the timescales and the scope of the problem make international action very difficult. There are obviously very large stakes, and every country in the globe is implicated. Climate response timescales are long, meaning that the effects of mitigation that are undertaken today will not be apparent except for many decades into the future. So think of 50 years from now. While in contrast, the political timescales are generally very short. The attention of the politician that makes this decision is a politician who is going to be reelected or not within the next 4 years. Contrast that with the 50 or 100-year timescale that is required for us to see the results of our actions. And nevertheless, we need to come to consensus on mitigation. And the recent announcement from the Obama administration that aims for a 30% reduction in emissions from power plants south of the border is a step that's an important step in the right direction. So it was mentioned that I have an involvement in the Intergovernmental Panel on Climate Change, and it's a key player in all of this. It simply studies the problem, but it's an organization that is supported by all governments in the world, that all governments contribute expertise to and participate in. And the reason that that's important is because we need a way of coming to a common understanding of what the problem is. Scientifically, a common understanding of the possibilities for action, a common understanding of the impacts. And it's only when we have that common understanding that we can come to agreement on a way forward. So climate change is a transdisciplinary topic, and that means it's one that requires the integration of diverse forms of research and diverse problem-solving approaches. It involves a huge number of disciplines, a few of which are represented here today. We need mathematicians, we need statisticians, we need physicists, we need chemists, we need biologists, we need philosophers, we need sociologists, we need economists. All of these people think about this problem. They all have different ways of solving problems, different ways of evaluating evidence. And the way in which you make progress and the way in which I've become engaged in this is by bringing one set of skills to a problem that is understood differently by a different group of people. And that combination of different types of expertise eventually leads to an understanding that we can all appreciate and all accept. And finally, the question then is, how is this relevant to you, the graduates who are being honored today? And you're here today because each and every one of you has successfully completed an important step in a lifelong education process that the Chancellor mentioned. And that education provides you with the background and the tools that are needed to clearly frame questions and pose pathways to solutions. So many of you indeed have developed this capacity in more than one discipline. You've taken combined honors, for example, studied mathematics and statistics together, or statistics and computer science, whatever the combination may be. So you've done this both through your studies and through your work experience that you've gathered over the course of your studies. And as you enter into your careers, the advice that I would give is not to be afraid to use these tools, and not to be afraid to use your abilities to their fullest, and also not to hesitate to invest strongly in additional learning, particularly in other disciplines, in areas that are outside your comfort zone. And above all, do not be afraid to engage in science on the complex issues such as climate change that challenge our society. I've used climate change as an example, but there are many global change issues where your skills are much more than relevant, or in fact are necessary. The fact that you may not have the necessary knowledge or insight to contribute to their resolution today simply means that you need to learn more. And your brilliant success today, and it really is a brilliant success, demonstrates to each of you that you are capable of learning much, much more than you have already learned. The science of climate change entails enormous challenges, but nevertheless, I remain optimistic for the future. My optimism in the face of the grave challenges that we face collectively stems from you, the graduates, the young people who are taking the challenge of pushing forward the frontiers of science and who increasingly understand the importance of working in cross-disciplinary and transdisciplinary settings. I salute all of you for your success and express my fervent hope that you will continue to push your intellectual boundaries and that you will not shy away from engaging in the challenges of the key global and societal issues, such as climate change, that are only too evident all around us. Thank you very much.